Welcome to MetalQuest Unlimited. My name is Scott Volk. I'm the Vice President and Chief Operating Officer. We are a contract manufacturer with locations in Nebraska and Idaho. In 2011, we brought our first robot. Now we're up to 15 robots, and we also all have our machines and our systems communicating with each other and with both locations, both in Idaho and Nebraska. If you want to come along with me, we'll go out on the floor and I'll show you around. So this was the first automation project we did here at MetalQuest back in 2011. We're making a butterfly valve disc. We have 4 different machines that we can run this on. What we decided to do was make a robot that was flexible, that we could move in and out as we needed it, and move around the different machines as we need it. So we came up with this enclosure that allows us to wheel this up. We can lock it in place. We're just holding this with a couple of Destaco clamps. We have 3 connections. We have an air power and Ethernet, so in a matter of a few minutes we can have this thing connected and up and running and making parts. Then when we need to move it out of the way to work on some fixturing or tooling issues or something like that, or if we have a really short run job where a robot doesn't make sense because there's just a few parts, we can go ahead and we can just move this out of the way for a little bit. And like I said, we can also move this to other machines and do other things with it. And also the way we're able to get by without having to stake this down on the ground is this robot has an option on it that allows it to go into float mode. So we just go to a known stage point between the fixturing, and then we let the robot go into a float, and then the fixturing comes and the machine will seat itself up against the fixture, and then the robot turns back on, moves out of the way, the door closes, and off we go. So we'll wait here just a second, and perfect timing, the door's opening up, the robot's going to go in, it's going to grab the part. Since we have a vision system on it, we have both raw and finished parts here in the tray. It's going to come over, it's going to find the open spot, drop the finished part, it's going to take a picture, find the next casting, pick that casting up, move it in, drop it into place, wait for the tailstock to come up and fixture up against it. Robot moves away, door closes, and we're off and running again. This was our second automation project, which we took on a really big project to start for our second project, but our guys did an outstanding job with this. We're doing a high pressure plug for the oil field industry. What we're doing here is this is a gantry robot, gantry FANUC robot. That robot is feeding an Akuma lathe, an Akuma grinder, and then we also have a pin stamper in the back. So the basic process is it loads the raw material into the lathe. When it's done with the lathe op, it puts it in the pin stamper, and then from the pin stamper it goes into a cart. The reason we don't have the robot go directly to the grinder is we're able to feed multiple machines into the grinder, trying to make the most out of that grinder time, since the cycle time on that grinder is much, much shorter than it is in the lathe. So you feed from the pin stamper into a cart here, and then separately we move those carts into the grinding cell. The same robot takes over and will feed the parts into the grinder. All of the machines, all the equipment are talking with each other, so the grinder knows the priority of this cell and knows that the lathe is first priority, the grinder second priority, and then the pin stamper third priority. If it would get a call from all 3, it's going to go to the lathe first, and the grinder, and then the pin stamper. We're using a vision system like we're doing a lot of other places. Everything about this cell is customized. We designed our own carts. We designed even our own cardboard boxes and pallets to make this an efficient cell and making these parts as cost effective as possible. So this is the most complex and automated cell that we have in the shop. We are making retainer segments for the oil field industry, and we're also making some other round parts for different customers. That's the beauty of the cell, is it's really flexible, so we can do a lot of things with it. The main thing that we're doing is retainer segments. So in this cell we're able to run 3 different part numbers at the same time. The Op10 machines that we use are an Akuma 2SP, which is a twin spindle machine that has 2 outward facing spindles, and it has a stacker system. So what we're doing here is the rings get loaded into the stacker. There's a series of robotic arms that will first pick up the ring. It'll take it into the machine. It does the first op in spindle 1, second op in spindle 2, and then it takes it out and brings it over and puts it on the conveyor. After the parts come down the conveyor belt from the lathes, the next thing that is done is we have a robot that will pick up the parts, and it demagnetizes the part, which is what it's doing right now. And then we have 2 different pin stampers, so we can run 2 different part numbers through the cell at the same time. So when the robot waits for the pin stamper to get done, if it's running, like in this case, it's the same part that's going to load onto the pin stamper. Once the pin stamper is done, this robot will grab the parts, load it into a vertical machining center where the retaining segment will get split, which is doing right now. After those parts come out, it gets put on a pedestal so it gets deburred. After it's off the pedestal, and then after the retaining ring is fully
marked, which is still doing right there. This robot will come over and grab that ring, get it over and in the weight position and wait for the vertical to get done. Then our robot up there will load the next part on to get pin stamped. This robot here is then picking up the parts and it's deburring them. We're doing some really cool things in this cell. I could talk about this all day, but to keep this short, one of the really neat things we're doing here is we have 2 different deburring wheels. They're going opposite directions, which allows the robot to just make one pass to deburr instead of going back multiple times. When we first set the cell up, we found this was our bottleneck for the entire cell. So by reconfiguring how we're deburring the part, we were able to make that part get deburred a lot faster, and we're able to get to the parts of the cell a lot quicker. After the parts are done getting deburred, then this robot here will take the parts that have been dropped off from deburr, and they will, once there's a full row of them, they get picked up and they get put into a dip tank with rust prevent. The rust prevent's then dripped off and the parts are sat, and it sits for a period, I think about 10 minutes, and gets dried off. Then this robot will take those dried parts, picks them up, and it puts them in a cardboard box. Once the cardboard box is full, this same robot will go and it will build a new cardboard box. Then it will kick the full box out so the operator can grab these parts and do final inspection. And then the robot will just sit here and wait if it needs to pick more parts up for the rust prevent or get ready to build another cardboard box or load parts in the box. The operator will do a final inspect. They stamp the parts and show they're certified. We put them on a cart and we take them over to shipping and get shipped out to the customer. One thing that I think is really important to point out, and it's something I'm super proud of, is that everything that you see here in this cell was designed, developed, integrated, and built right here at MetalQuest. We're fully self-sufficient. All of the engineering, all of the processing, all of the integration, everything is done in-house. So we have a fully automated cell with 8 robots, 3 lathes, and 2 vertical mills that are making upwards of around 40 some part numbers in this cell. We're running 1 to 1.5 operators per shift in a fully autonomous cell. It's something that we're very proud of, and I think it showcases really well the talent and ability of our crew here at MetalQuest. So this robot here is doing a great job of showing the creativity of the people here at MetalQuest. We're doing a spool valve for a customer, and we have to do what we're calling a zero op, where we're just facing one side of it so we can load up in the fixture in our horizontal. This was something that when we first got the job, we were having a person stand a machine for a while and do. We quickly transitioned to having this robot do this, and we were doing it in a vertical mill. Everything was working great. The problem was I needed that vertical mill scheduled for other things and some new jobs we had coming in. So what we did is got with our automation crew and talked about moving this over to a knee mill. Our knee mills, they weren't getting used. They're getting used, but not all the time. And like, let's not fill up equipment that is being used all the time. Let's move it to some underutilized equipment instead. So took a little creativity, but I have an amazing crew here that does a great job. They came up with this system here using that same robot concept that we're using in other areas. We'll roll the cart up, lock it in place, and the robot's able to pick up the castings. It has a vision system on it, like in some of the other areas in the shop. Refixtures it, puts it in the vise. The knee mill takes over, does the facing mill operation. When the facing mill operation is done, the knee mill lets the robot know that it's done, and then the robot will go over, it'll pick that part up, take it back, sit it back in place, and then pick up the next casting. This is one of our newer projects. What we're doing is a lathe and mill op in our Akuma LB on a small little casting. This was the second project we did where we do 3D printed fixtures. When we did our first project, the plan was to do 3D printing, to do proof of concept, and then we were going to roll over and do machine and hardened fixtures. What we found is these fixtures, the plastic wears well enough that we don't really need to do that. So on this one, we designed these right off the bat with in mind that we were going to just use a 3D printed fixture. So much more cost effective. These last for quite a while, and when we do wear out, it's really quick to print new fixtures. Same type of setup we see in other places. We're locking this into the machine. The robot can do its thing, doing the load, unload, and the operator just needs to come over here and load the castings into the fixture, take the finished parts out. This is about a 30% operation, so this is a great example of us being able to do something to give us a cost competitive part to our customer while being really efficient and being able to not have to have a lot of labor, in a time when there's not a labor available right now.
Hey everybody, Brent Donaldson with Modern Machine Shop here, and if you just watched that video and you're thinking, boy, I'd like my shop to be featured in the View from My Shop series, then just send us an email at shopvideo@mmsonline.com and tell us what sets your shop apart.